session on building IoT solutions that can cope with satellite connectivity. We've got Windows behind Windows. This session, for those watching the recording, is done on behalf of the Azure Cloud Commanders Microsoft Learning Room. So we're a learning room that uses Microsoft Teams. We're a community where you can come and ask questions, and we deliver sessions like this. Whether you're doing work on certifications or just want to learn more about your Azure knowledge, make sure you join my learning room and any others that are interested. We've got like learning rooms on AI, data. I think there's a Fabric learning room now. So we're all here to help you guys use the technology and learn it as much as possible. So this session will be recorded for those that can't make it. Just be aware, if you do not consent to being recorded, please disconnect your line. Attendee names are hidden by default in the recording, but if you come off mute or show your camera, then just be aware that it is getting recorded. This session is quite inclusive. We're a friendly group of people. Just be aware that be welcoming and respectful to everyone. Sorry, I'm still waking up in the morning, but everyone's coming from every different angle here. The technology and the capabilities that we may discuss today, you may have already been using it for a couple of years, but then someone else in the session may only have heard about these technologies today. People come from different diverse backgrounds. Just be welcoming. No question's a stupid question. And we're just really lucky to have Bryn today. So Bryn, do you want to share your screen and do an introduction and start talking us to him about the amazing IoT technology?
How's that? That's it. The magic happens.
It should be switching over. You have to share your screen. I've given you control of my computer.
Share the screen.
Stop sharing.
Oh, it's done.
PowerPoint Live. Go PowerPoint Live.
Yeah. PowerPoint Live. Where do I aim for that?
In the share button on the top right-hand side, you should see that PowerPoint Live. That you tested earlier. Yeah.
PowerPoint. It's how's that? Not working. It's not working. I basically just got a picture of you. Oh yeah. I'll go back and do it again. Here we go. Tech file.
It is so for those watching. It is 7 o'clock in the morning in New Zealand. So I think the computers we're using also need the coffee that we're consuming here. So
okay, PowerPoint Live is grayed out. Presenter mode. Which one should I aim for? So we'll do that one there. How's that?
It's coming up. Yep.
Have coffee.
Have coffee. Win life. Yep.
Yeah. Drink lots of coffee, make mistakes faster. Here we go. My name is Bryn Lewis. I'm an MVP. I've been one for 9 years. I've sort of wandered through being an MVP. I started off as a Windows dev MVP, then moved sideways into embedded, but then they killed all that. And now I'm in IoT. There's actually a series of plaques in a courtyard at Microsoft of all the products they've killed. And I think my name, or I could be related to maybe 6 of them, which have been killed over the years. So I started off when IoT was originally called SCADA. I started working in the power industry and process control. My first serious SCADA factory management project was managing a switchyard of a small power station, a hydroelectric power station up in the back of Ranfurly in the Maniototo in New Zealand. And it took a lot of focus because failures in the switchyard were going to be expensive, particularly when we were connecting to the national grid, because our tiny little power station trying to make Manapuri go backwards was going to be problematic. There are two IoT MVPs in APAC. There's me and David Jones. In Australia, there's about 40 odd around the world. So today's topic is going to be about satellite IoT. This one's about Mariota, who are an Adelaide crowd. The first one was about Swarm, but they got bought by SpaceX. And then Elon said, yeah, no, we're not going to do this anymore. Bought them. We're going to kill them. You've got a year. Basically, we're going to turn the network off. We're not going to sell any more units. And the alternate technology that you need won't be ready for a year. So I was off like a flash because you can't have stuff sitting on the top of a mountain, which you can only visit by helicopter, being held to the whims of Elon. So this is what I do. Mariota lets you send messages to and from satellites. I'm currently on the beta 7 of the downlink software. It's hopefully going RC, well, it's actually RC now, so hopefully it'll be ready to go. These devices, like this one, will run for 5 to 10 years on a pair of lithium AAs, depending on how good your software is. The messages are queued on the device, and then back office, which is hosted in Virginia in the US, calls your back office, in this case, some plumbing around Azure IoT Hub. So the median latency for message delivery is about 3 to 4 hours. The downlink messages, they say, wait for 2 days and give it, at the worst case, give it 4, because the satellites orbiting the Earth, the RF signal is uploaded in a specialist file. They use satellite as a service. Basically, they buy bandwidth and processing power and antenna access off a satellite provider. So they pre-processes everything on the ground and then just upload it and effectively play it back as satellites go past. So you can see this is from my backyard. The satellites, I get uplink and downlink windows, and the higher the angle of the satellite, the more likely I am to get coverage. After a while, I can get 95 to 100% confirmed, 95 to roughly percent uplink, and downlink I get roughly 45% delivered. I can do 50 messages a day, which gives me a total of 1K a day. You get 160 bits. So you need to look at something like an industry standard. LPP is the common one, which is the low power protocol, which provides a bunch of code for compressing messages to the minimum possible size. So that modem that I waved around before wakes up every 2 to 3 hours, depending on whether it's moving or not, squawks off a couple of messages with the latitude and longitude and the quality of fix, and it's back to sleep again until the next time it's got a message and the next time a satellite will be flying past. And no pictures. No, I've got no pictures. So this is the device I waved around before. If you want to give it a try, you can pick up a developer kit from the crowd in Australia. Comes in a nice box. You've got a USB dongle to emulate the satellite network, so you don't have to wait for 2 hours. You get 3 months of free data and you get access to the cloud SDKs and a bunch of other stuff. I'm looking at a .NET Nano framework device to drive it because I was a contributor to the .NET Nano framework. I've been pretty busy recently doing ML.NET apps on a device like this. It's a NVIDIA Jetson, which has got an ARM processor and an AI chip doing image processing. The SDK that you get as a developer runs on Ubuntu. Make sure you've got the right version. GCC without a proper editor is like going back to the Stone Age. Data plans start at $1 US a month, which is pretty good. So pictures are back now. I've got a sensor locate tied to the front fence. Sensor locate is about $200, $300 Australian, and you can also buy the modem modules and an external antenna. So for size, that's my hand, and that's a modem module. And then if you want to build a device, you need to do the first cut, have an antenna. Don't build your own because it's hard. RF is a dark art from my days in mobile radio. So it's effectively, they call it the mouse, just to give you an idea of size. The mouse antenna, it's got good gain. It's really stupid, hard to kill. Because they're Australian, they have considered the specialness of our part of the world. It's got an IP65 enclosure, which means it withstands heavy rain and dust ingress. And this part of the world, you need to have UV resistant plastics. I've had bits of kit from China just disintegrate because the PVC isn't UV resistant. So this is the architecture. Essentially, it's a web API which calls the MyRiota Cloud API, and the MyRiota Cloud API calls back to it. It consists of some Azure storage queues, which are pretty classic technology. And then it provides some identity translation. It's effectively an Azure IoT Hub identity translation gateway. It maps devices in the field to connections to the IoT Hub, because with IoT Hub and other IoT technologies, you often can't send a message to a device until it's connected. But the problem is you can't have a device in the field connecting. So what you do is you simulate a connection from inside a Azure function that doesn't shut down. It just runs there continuously, but every so often you can see the Microsoft plumbing restarts it because it connects back to the MyRiota Cloud and downloads the list of devices in the field and reconnects. Also uses the device provisioning service, so you can put these devices out in the field, and when they connect, they will automatically provision them. It understands DTDL2, which is the device DTDLV2 device something definition language, and so that it can be a totally automatic provisioning. The device can connect, and IoT Central can get the message. It can go, oh, it's a type of MyRiota tracker, and automatically provision it. So it can be totally seamless. One instance can manage about just under 1,000, like mid 1990s. So I think I've tested it up to 500, but there's a point around 995 where the connection pooling flops you to another connection. Uses MQP rather than MQTT, which is not cool these days, but it's not as cool as Azure Event Grid plus MQTT, but MQTT wouldn't work. So MyRiota developers had published an open API spec. So I fired it up generated the client, and it worked until it didn't. The Open API definition was wrong, which was a pain. I only needed a couple of messages, so I fired up REST Sharp and called them directly using object serialization, and it just worked. I had to sort out a couple of resource leaks, but because it was running for months at a time, but once I'd done that, it was really robust and much more reliable. IT Hub is the glue of Azure IT. It supports HTTPS, MQTT, AMQP, and doesn't do any of the more commonly used protocols like TCP over UDP, which is CoAP, M2M, lightweight M2M, and stuff like that. It just works. And the pricing is reasonable. You can get a free version, which lets you do a maximum number of messages a day. And then it basically scales up infinitely. You've got to use the concept of a customer group, which you have one for each application reading messages from the IoT hub. Yada, yada, yada. Last time Microsoft said anything, they had 150 million devices connected to IoT hubs around the world. Yeah, everything from posters to wind farms. So the process of managing the tens of connections is handled by a lazy cache, which is a very good piece of code. Basically, it's a NuGet library which manages caching for you in a thread-safe way, and it's a read-through cache. So I say, hey, open me a connection to the IoT hub, and then an event comes out the other side of it saying, hey, connect to the IoT. I need a connection for this, and it takes care of all of the threading because this can be have the same device trying to connect at the same time. You can have a downlink message and an uplink message. So this takes care of the threading. So say the downlink message goes first, it reaches in, grabs a connection. If the uplink message hits it at the same time, it basically waits until the downlink message has created a connection. And all of the really hard stuff, which people usually get wrong, is taken care of for you. So this is the desktop console running. It's an Azure function. It's a queue trigger. I have a web API rather than a Azure function, which receives HTTP posts from the back office of my router, drops them into a queue, and then my Azure function picks them up and processes them. Had lots of different approaches, but this one sprang into life after I found that the Azure functions for HTTP were taken too long to start up, whereas I could auto start a web API. So this is what it looks like. This is the payload of the message. You get a bunch of useful information about when the message hit the edge of the MyRouter network, when it got processed, and then when it got sent to you. And the 20 bytes come as a base 64 encoded payload. So you've got to unpack that. I use storage queues a lot because they're real lightweight, real fast. And I'm going to do it again. Sorry, Luke. Internally, we refer to these tiny little apps, which all they do is receive messages as a craplet. And you can work the rest out for yourself. I drop them into a queue so I don't lose anything when Azure or I restart and shut anything down. So if my function, which plays the messages to the IoT hub, explodes, they just get dropped into a poison queue where I can come back and figure out why it died and resubmit them in a bit.
Sorry, just while you were there, I was wondering why you were using storage queues versus service bus.
Service bus was a bit chunky. The storage queues are real lightweight and real fast. I worked on a gig where we were running them up just under 600 transactions per second. And though that's not important for this, I like them a lot. They're real easy.
Yeah. They just work. Yeah.
Yeah. They're too stupid to die, which is great.
I like that. Yeah.
So this is the gob of JSON that I drop into the queue. I unpack the messages and send them across. It's got some certificate validation code, which if you're doing something really serious, you can use. It's going to do a bit of work with the Australian Defence Force, so I hazard a guess theirs is most probably top secret. I think it's like a black box for soldiers. So um, when you get these 20 bytes, you've got to process them into something useful, which is usually JSON. So I use a tool called CS Script, which compiles C# code into a binary, which you can then run, and it runs close to real time. So there's a bit of overhead with the compile process. So when someone hits my um, requires an evaluator for the first time to process a binary gob of binary into JSON, it hauls the JSON out of a storage blob, compiles it, and then caches the binary. And then as the messages arrive, it executes the binary. So it's got a fairly standard interface. So basically, call the evaluate method with the payload, and it returns a JSON object. One day I'll modify the code so they run inside an app domain. So you can use, two people can use it. Currently, it's just easier and cheaper to make every user spin up a function. Making it multi-tenant would take maybe a month's worth of work. I can't be bothered to do that for the $100 or whatever it costs for an additional instance. So you basically got a bunch of C# files, and they take the inbound messages. There's a uplink and a downlink folder. They grab those messages and they compile it. I've got a data console app so that you can test formatters, uploading and downloading files, and then you can configure attributes for the individual device or the class of device, so that you can say, hey, this is a tracker, always use this format. I don't recognize what that device is, I'll use the default one. Or there's a flag set on this device, which though it's a tracker, it's actually tracker v2, so I'll load the tracker v2 one. There's more configuration parameters than is necessary, or it's monumental pain to test. So this is basically the start of it. You get a C# structure. I usually copy the C# structure into the top of my formatter so I can figure out what's going on. And that's the code for a formatter. Basically, call the evaluate, I create an object, I check that I've got a message, I add a sequence number, which is good. I, in this case, convert the location. You can see that it's divided by 1,000,000. So this is offsetting it so that you're right in the meat of a double, so that the accuracy is improved. And then the important thing is, if you're using Azure IoT Central, a bit at the bottom, the IoT Hub creation time UTC, because the message might arrive a day or two after the measurement was taken. So you really need to put that on for Azure IoT Central, which I only use for a dirty test harness, so that the messages arrive at the right time. So that's what a message ends up looking like. That's a gob of JSON, which my payload formatter has spat out, and it's got all the necessary information. And I've also included the actual original base 64 payload so that it can help with debugging. I can look at these messages in Azure Storage Queue, which I would Azure Storage Manager, which I used to show the payload formatters before, and copy and paste it out. So in Azure IoT Central, you configure templates which are related to different DTDL v2 configurations for devices. So you have to reformat the messages, which is done inside those payload formatters to suit Azure IoT Central. And word of warning, the Azure IoT Central positions have a very specific format. Even though it's JSON, it's actually case sensitive, which gave me a buzzing noise at one stage. That's basically the template for the messages we were looking at just before. Then you figure out the format of your messages, you design your template, and then messages start arriving. Everyone high fives, job done. Then as messages arrive, something doesn't work. So you fire up the diagnostics and have a look at the payloads. And this is the process payload, and then down off the bottom of the list is the payload that it couldn't get processed. So you can also drive it with the Azure IoT Hub. So that's the text on that one. Luke, looks a bit bad at this end.
Yeah, it's pretty
And
it's pretty small, but you can, for the people attending, you can use your control key and your mouse scroll wheel, and you can zoom in.
So this is the gob of J. Oh, sorry.
Oh yeah, just I'll put it in the chat as well.
Yeah, this is the gob of JSON that you get back in Azure IoT Explorer. So there's Azure IoT Storage Manager and Azure IoT Explorer. These let you generate, view messages, IoT Hub messages, and access storage queues, shared drives, individual files, containers, a whole bunch of other stuff. So I've quite regularly got those running on my desktop. So then after all the high fives, you can then set up templates to send messages down to the device. So there are three types of commands. There's the no payload. That's the sort of Homer Simpson, lights go on, lights go off. And then there's odd thing about that one, it's not actually blank. It contains an @ symbol. And I think that's because when you try and send an empty message with Azure IoT Explorer, it actually puts a single space in. And a single space is a valid piece of JSON. Single value payloads, which is something like set the fan speed to medium or upload every 5 hours. And then there are multi-value where the payload is JSON, and that's where the format is used quite a lot. And the downlink formatted chosen is based upon the name of the command. So in the configuration, you can say, hey, for this command, run this formatter, and then if it's not got a payload, send this payload when its lights go on, or send this JSON payload when its lights go off, and then that JSON payload gets processed by the payload formatter and converted to up to 20 bytes of payload. So you can see here where it's running. I've got connection strings, all the necessary provisioning information, and then about 2/3 of the way down, you can see the lights go on, lights go off. So you press the lights go on button, that gob of, and you press the gob of JSON with light true goes on, and then that's processed by the lights on or lights off or on.cs. So if that hadn't been run before, it'll go, oh, I haven't got that in the cache. It'll reach down into Azure storage, pull it out, compile it on the fly, and then the next time that particular gob of JSON goes past, it'll run pretty much the same speed as code in your application. I did look at caching them for the binaries for longer, but realistically, messages don't arrive that fast. They're queued, and people aren't going to notice the additional 150 milliseconds it takes to grab it and compile it. So in here, you can see the output of the payload formatter, where it's taken for a parameterless command, where it's taken the piece of JSON and it's about to process it. That's the payload formatter. So for a downlink message, it's for a downlink message, it's looking at the fan speed, getting the value, checking it's got a value, and then putting the value in a 2-byte payload. In this case, the first byte is number of the command. Sometimes it gets to the point where you actually use a nibble 4 bits. for the version command, version information, and then you have a bunch of other information which follows after it. So, and then you can see that's the payload which is going to get sent down to the device. The aspect ratio of that is a bit of a problem. So then for an Azure IoT Hub downlink, you basically type in the JSON, making sure you get it right. I copy and paste it from Notepad when I'm doing live demos, and then press go. The message isn't queued. In the future, it will be queued inside the Azure IoT plumbing. The main reason for that is currently the Myriad back office doesn't queue stuff. I've been talking to them about it, and they said they'd do it. It's just been taking a wee while. So, oops. So that's basically the architecture. Payload formatters, which are compiled, stored in a storage account, Azure IoT Hub with external integrations you can wire into the back of the Azure IoT Hub logic apps, calling functions. If you've got a lot of devices, the device provisioning service can provision a device, smearing the load across multiple IoT hubs. You can use an Azure function, and you can base it on something like fastest response. So I have some devices for another gig in Europe and some devices in APAC. So it looks at the geography, and if someone connects a device, say from Ireland, it will automatically provision itself in the North Europe hub. Whereas if someone hits a device in Papua New Guinea, it automatically gets provisioned in Australia East, which is in Sydney. There's an amazing amount of magic goes on behind the scenes. And you can see the poison message queue where stuff ends up if it fails. On the downlink side, if the message fails, it's logged into application insights, and in some cases, an email is sent to a human with some rules. It's been running for 3 to 4 months at a time without stopping. Usually, the 3 to 4 months is more a limitation of Microsoft restarting things because they've got a patch and stuff. Currently, it runs on Windows. I was going to deploy it onto Linux, but I wasn't expecting any difference because it's only boring C# code. So, any questions?
If you've got questions, feel free to raise your hand or write in the chat. Brent, I've got a question.
Yeah.
And it's more around the sort of the timing of these messages, right? So obviously with this kind of solution, you're limited in terms of where the satellite is. But you've already kind of talked about it. I think it's something that it's easy to forget in this world where everything's just connected all the time or appears to be connected all the time, right? So
there's no gigabit fiber.
Yeah. That's right. Yeah, there's no space elevator that all that cable is going up to. So this type of solution that you're looking here to do here, is this the runs that you would usually do? Like, this is not a real time sort of IoT solution. Like, I need to monitor the temperature of a fridge, or this is more of we have a batch processing that needs to happen every night or 3 a.m. in the morning, or whenever the satellite overhead spins around, that for a device that's unreachable, like you said, without a helicopter. So
Yeah.
this is not a real time based thing. This is more of okay, the device in the mountain needs to batch the information and then send it to the uplink. And
yeah, it's a trade-off. It runs on 2 lithium AA batteries. Basically, this is some spare batteries. Runs on 2 of those for 5 years if you write your code well. So you can go and chuck it on top of a mountain and not expect to revisit it for 5 years. The sort of applications that people are using it for, mine are in agriculture, where it's things like soil temperature for forecasting grass growth. people put them on top of shipping containers and trucks and stuff like that for
Oh yeah.
tracking them. I've had one on top of the Sparky who goes around and installing our farm systems for testing. Another example they use is the big crawlers in the mines in Australia, and they have grease, drums of grease. And when they're down to the last drum of grease, it sends a message next time the satellite is over saying, hey, come and give us a couple more drums of grease. Uh, got a couple more slides if anyone's interested.
Oh, sorry. Yeah.
Um, uh,
Yeah, take over from me.
yeah. Uh,
Yeah, in a previous life, we were doing work around gas. So I think you're requesting control of my screen instead, so I'll just stop sharing.
yeah,
Like LPG waste scales
yeah.
and
This would
things
be
like that.
ideal for that. It it's the ideal solution for that because it's not got to be that timely. It's
Mhm.
just got to happen every so often. We use it out in the field for the soil temperature when that needs to be emptied, stuff needs to be topped up, stuff like that. So it's all stuff which doesn't have to be so timely. And it's actually cheaper than cellular because you can uh, cellular connectivity can cost dollars a month, whereas this is $60 US a year. And for the benefits of connectivity anywhere, it's pretty good. So for $5 to $10 a year, it works pretty well. Uh, any
It'll
questions?
cost you more to get people out there to do this manually a lot more.
Yeah. So here we
Just
go.
just while you do that, is there any resources that like the students and people watching this can go to if they want to learn more about this kind of things that you would recommend?
The Jim Bob Bennett, where was I up to, did a series of things about IoT. Of course, there's my blog. My blog is a wealth of useful information and uh, me basically figuring out how stuff works. For example, with the uh, Jetson Nano device, there's a lot of discussion about how to make ML.network. With IoT devices, it's a bit of an odd thing. You've got to have a foot in hardware, which springs from my days of working in radio. So I can write software for modems, LoRaWAN at one end of the spectrum. I'm writing software for devices that size. That's a LoRa modem. It's got a range of 5Ks, maybe 15 in a rural area. Um, through to back office, scalable back office systems, and that most probably fits nicely with my background in anti-money laundering and counter financing of terrorism software, which I worked on for a few years, and online gambling. Online gambling is really quite interesting because it's a really good scaling. We found that we did in-play betting so that if someone, say like in those days, Beckham twisted their ankle, or another one was tennis, you'd see something go wrong uh, on the court, and then we'd get waves of people arbitraging against themselves. Professional gamblers do arbitrage just like really good financing people do. So we'd see a wave of people who are sitting on court changing their position. Then there would be people in country watching television, and then there would be people watching satellite feed, say over Sky in another country. And that was a really good way of testing scale, particularly with in-play betting on tennis, horse racing, stuff like that. One of the other crowds, not ours, actually, we sort of got taken out by it. There are three possible outcomes in a football match. There's uh, one team wins, one team loses, and a draw. But there's actually a fourth outcome, which is match abandoned. So the other company, they had a problem with Russian mafia betting on match abandoned. The game would start, and then they'd go to the substation at the ground and kick the door open and smash stuff until the lights went out. So the game would be abandoned. I am so glad I didn't work for that on that one. So, as a humorous aside, quite a
Yeah,
lot.
that sounds like a really good session for another day, actually.
Yeah, no. I used to be able to do the odds. We did peer-to-peer gambling, so I could do the odds in my head after 6 months. So quite a lot of systems when they start up before they get a fix. For GPS, you need 3 satellites to get a fix minimum, and then you need a fourth one to get which hemisphere you're in, and then after that, bonus give you an increase in accuracy. In the old days, they used to have selective availability, which meant your device wandered around in a 100-meter circle. And it always struck me as a bit odd, but it was about the Americans using GPS to know where they were launching their ICBMs from, because the first GPS unit was as tall as me and as wide as my shoulders in a rack mount cabinet. It always struck me, though, that if you're lobbing a multi-kiloton nuclear weapon in a silo somewhere in Siberia, you didn't really have to be that accurate. So 00 is off the coast of West Africa. Once worked on a job where we had the software wrong for crossing the Greenwich Meridian. So every time a truck went across the Greenwich Meridian, the position was temporarily wrong. You might think that's not a problem. Well, if you're calculating average distance covered, and when you first open the map, it has to show both of those points. So that can be quite problematic. Basically, there is 00 off the coast of Equatorial Guinea. It's surprising the number of devices which end up there. It's where GPSs go to die. So there is nothing there. There's a buoy. Some Americans and some French scientists went there and dropped a buoy on exactly 00. If any of you read Thomas the Tank Engine as a child, and there was Sodor, the mythical island of Sodor, well, there's a mythical Null Island, and Null Island has got a history. It's got people who live on it. It's effectively just like Sodor, but all there is a buoy moored at 0 degrees latitude and 0 degrees longitude. So that's me. I've done my dash.
Oh.
I'm now awake.
Yes, yeah. Nothing like all the information that you've supplied to us to wake us up and get our minds spinning. Thank you very much for coming and attending and speaking and telling us all this practical information. I think it's definitely caused me to rethink potentially what I knew and just how I would go about approaching a solution like this.
One of the great things with this is global roaming. You don't have to get one of those special global roaming SIMs. It global roams by default. I can take one of those, step off the plane in Melbourne, and it just works. I can have it roam anywhere in the world without my global roaming provider having to have had negotiated an agreement with the local cellular provider. It'll work even in the heart of Africa, where the network providers used to buy secondhand 2.5G gear from European and other telcos and deploy it as an interim step before they bought 3 or 4G hardware. It just works anywhere in the world, even at the poles, even where there's no cellular coverage. You could go down to Stewart Island, turn it on, and it would just work. They pop them on the top of shipping containers or other important cargo like that, and they can follow them across the world. Okay.
Yeah.
Please give me some questions.
Right. Any questions, anyone, before we finish it off? I think everyone's probably still taking it in.
If
One
you're
of the
in
recommendations I gave in the chat was camel case. So when scripting, because you touched on like the JSON payload and how it's case sensitive, I think being able to learn and use just type out using camel case can save you a whole lot of
yeah,
struggle later on. At least I know it does in the Azure world.
yeah. In that case, JSON is not case sensitive, but just that one particular payload in Azure IoT Central, it is case sensitive. And it took me a while to figure that out because without thinking, I was typing camel case in Postman and Fiddler. So it was working when I tested it on my desktop.
Mhm.
But then when I deployed it into the field, it'd stop and I'd get the message and it wouldn't be able to I'd get the message, it'd unpack it, submit it to Azure IoT Central, and then Azure IoT Central would go, meh. So,
Okay.
um,
Yeah, I
it,
think we'll leave it here. But thank you for waking up early and coming and delivering and talking to us about satellite connectivity with IoT.
next time I will have played with PowerPoint online before we go live.
It's all good. Changing monitors doesn't help either.
Yeah,
Thank you.
no problems. See you later.